All right, to end our discussion of finding volume, we're going to take a look at finding the volume of this hammer. It's not a liquid, so we can't just get a graduated cylinder and pour it in. It's not a rectangular prism. There isn't an exact width all the way. It's that wide here, but skinnier here, and a lot wider here. So we can't use our formula, length times width times height. So what we do is we use a process called water displacement. And a few years back, somebody called it water push out of placement. And I think that's a good description. Basically, you take the volume, we'll call it volume 1, of the liquid without the object in it. Then we will slide the object in. You'll have to pretend that we can actually put the hammer in a graduated cylinder, and we'll call that volume 2. As you notice, by Archimedes' principle, an object displaces or pushes out of place the same amount of water that it takes up. So we take the second reading, which is the volume of the water and the hammer, and subtract the water out of it, and that will give us the volume of our object. All right. Now the only problem, though, is that all of these are in milliliters. So what we get is the amount of water that was pushed up by the hammer. Well, as luck has it, 1 milliliter of water takes up the same amount of space as 1 cubic centimeter. So when we get our volume in milliliters, it's a 1-to-1 relationship. If it pushes 5 milliliters out of the way, then it would take 5 cubic centimeters of space. If it pushed out 10 milliliters of liquid, then its volume would be 10 cubic centimeters. So that's very easy. So let's take a look at the hammer. Let's take a look at the water level. The water level right now comes up to this line marked 65. The top of the meniscus is a little bit more. So we're going to read it. Our volume, original volume, is 65 milliliters. Then when the hammer goes in, it rises. Now we have to make sure that we know our scale. So from one numbered line to the next is 5. And that 5 is divided into 1, 2, 3, 4, 5 intervals. 5 divided by 5 is 1. So we know the scale on this graduated cylinder is 1. So we can say the water went up 65, 66, 67, 68 to about 69. That is our volume 2. And if we take the difference, the water increased 4 milliliters, or the hammer pushed out of the way, displaced 4 milliliters of water. Now remember, if we look back here, every milliliter of water takes up 1 cubic centimeter. So we know that because the hammer is a solid, we can't leave it as milliliters, that the hammer would have a volume of 4 cubic centimeters. All right, let's take a look at another example. Here we have a fish, right? And our first step is to measure, again, the volume of the water originally and then the volume of the water with the object in it, and we're going to take the difference. We do this second, and we put it first, though, because it's going to be a higher value. All right? And we're going to get how many milliliters of water are pushed out of place. And again, for every 1 milliliter takes up the same as 1 cubic centimeter. All right, so we're going to change that into cubic centimeters because our little fish is a solid. So let's take a look and get the scale so that we know how to read our graduated cylinder. So from one numbered line to the next, from 30 to 20, that's a difference of 10. And it is divided into 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 intervals. So we know 10 divided by 10 is equal to 1. So our scale on this graduated cylinder is also 1. So the reading of our water is going to be 31, 2. So our initial is 32. And when the fish comes up, it pushes the water to 31, 2, 3, 4, 5, 6, 7, 8 to 38. 38 minus 32. It pushed 6 milliliters of water out of the way. And for every milliliter, that's 1 cubic centimeter. So the fish took up 6 cubic centimeters of volume, and that would be its volume. All right, we have one more example with the dinosaur. And again, just to set this up, we're going to take, remember, the volume of the water without the dinosaur. Here's 1. And then 2 will be the water with the volume. We'll take the difference and find out how many milliliters of water the dinosaur pushed out of the way. And then you're going to convert it to cubic centimeters. Remembering that 1 milliliter of water takes up the same amount of space as 1 cubic centimeter. Put kind of an equal arrow there. Okay, go ahead and pause the videotape and then see how you did. Okay, let's see how you did. We'll go ahead and start with finding the scale of this first graduated cylinder. So I'll start with one numbered line to the next one. The difference from 2 to 3 is 1. And then we'll go 1, 2, 3, 4, 5. It's divided into 5. So now we have to say 1 divided by 5. That would be 2. So our scale is 2/10. So as we take a look and count, this would be 4, 4.2, 4.4, 4.6, 4.8. So our V1, our first volume, is 4.8. Then they put the dinosaur in. And here's 5, 5.2, 5.4, 5.6, 5.6. All right, now I'm going to do this vertically. All right, and if we subtract, we're going to get 0.8 milliliters was pushed out of the way. See, 4.5. All right, so if 0.8 milliliters was pushed out of the way, then the dinosaur, because it's a solid, should have had a volume of 0.8 cubic centimeters. You can review this video as many times as you like, or you can come see me to try another example. Good luck!